Welcome to another deep dive.
Hey there.
Today we're plunging into, well, a really fascinating, often kind of hidden world. It underpins so much, from AI training to research shaping policy.
That's right. We're talking about non-probabilistic sampling methods.
Yeah, exactly. And our mission for you today is to really equip you to understand how data often gets collected in the real world.
We'll look at the practical side, the advantages, but also, crucially, the limits and biases. Think of it as maybe a shortcut to understanding the data sets you see every day.
And here's the hook, right? These methods, they're super practical, often cheap, used everywhere, AI, ML, social science. But, and this is the big but, there's a catch. A fundamental trade-off that can seriously mess with the insights we get.
Yeah.
If you don't know about it, you could be missing something critical.
Absolutely.
So let's unpack this. Non-probabilistic sampling. Sounds technical. If someone thinks sampling is like, pulling names from a hat, equal chance, how is this different? What exactly is it?
Right, that's the key difference. With these methods, that whole equal chance idea goes out the window. It means not every element in the population has a known non-zero shot at being picked.
Okay.
Instead of randomness, it relies on other things like subjective judgment or just plain convenience. It's a choice, but definitely not a random one.
Not random. So that must have some pretty big consequences for the data you end up with.
Oh, huge. Yeah. I mean, on the one hand, they're practical, cost-effective, great when resources are tight or you need data fast, maybe from tricky-to-reach groups. But the downside is they inherently introduce selection bias. Because it's not random, you're not getting the full picture, the full diversity.
Right.
And that really limits how much you can generalize your results. That trade-off practicality versus generalizability and bias, that's the core thing to keep in mind.
Okay, that sets it up nicely. But then why use them at all? If they're biased and you can't generalize easily, when are they actually the right call?
Well, that's the interesting part. Sometimes getting any data, even flawed data, is better than none, especially if random sampling is just impossible or way too expensive.
Right, practical limits.
Exactly. And sometimes the research question itself doesn't need perfect generalization. Maybe you need deep insight into a very specific group or just a quick first look. In those cases, yeah, they can be really valuable.
Gotcha. So it's not one single method then. There are different flavors.
Oh yeah, several distinct approaches, each with its own quirks and uses.
Okay, where should we start? Maybe the one that sounds simplest, like the low-hanging fruit, convenience sampling.
That's perfect. Convenience sampling is, well, exactly what it sounds like. You select data that's easy to get.
Like it.
In machine learning. Could be data sets readily available online. Or data just from one city or region, or maybe samples from people who just volunteer easily because they're right there. It's all about minimal effort.
Okay, so like training facial recognition using only social media photos where people opted in.
Yeah.
Easy to get. But
yeah.
What's the catch there? What bias creeps in?
Spot on. The bias is mainly availability bias. Your data set will be skewed towards the people, the places, the contexts on that specific platform.
So the model works great for those people.
Exactly. It might work brilliantly for, say, white users from one country, but then fail miserably, unreliably with people of color, different ages, different lighting. It reflects the convenience sample, not the real diverse world.
Yeah, easy isn't always good. Okay, so that's convenience. What if the data isn't easy to find? What if you're trying to study a hidden group? Sounds like snowball sampling might fit.
Precisely. Snowball sampling is clever for those hard-to-reach populations. You basically leverage existing samples to find new ones through referral.
Like a network effect.
Exactly. You start with a few people who fit your criteria, maybe in a niche online group, and then ask them, hey, who else do you know like you? And the sample grows through connections.
I can see that being useful. What's the big plus, and what's the hidden bias we should watch for?
The huge plus is accessing rare populations or hidden networks, specific support groups, underground scenes, things you just can't find randomly.
Makes sense.
The bias, though, is homogeneity. Your sample tends to become very similar to the first few people you found. You get depth in that network, maybe, but you might completely miss other parts of the population who aren't connected to them.
Right, you get stuck in one cluster. Okay, moving on. Judgmental or purposive sampling. This sounds different, like it relies on expertise.
It does, totally. Here, an expert uses their knowledge to pick samples they think are most informative or representative.
So, not random, not convenient, but deliberately chosen.
Yes. Think of a medical researcher handpicking specific patient cases that perfectly show a certain condition, rather than just random files. It's purposeful selection.
Quality over quantity, chosen by an expert. What's the upside, and where can it go wrong?
The upside is potentially rich, targeted insights for specific questions, great for qualitative work or debugging ML models, analyzing specific failures. The limitation, it's all down to the expert's judgment. How good is their knowledge? Do they have blind spots? It introduces expert bias. The representative cases might just reflect what the expert already thinks or knows, you know?
Yeah, the human element. Okay, next. Quota sampling. This sounds a bit more systematic, almost like it's trying to be representative.
It kind of does, yeah. It ensures representation across subgroups by setting quotas. Like, you decide you need 30% urban images, 70% rural.
Okay, seems reasonable.
But, and here's the twist, the selection within those groups isn't random. You hit your 30% and 70% targets, but how you get those images might just be convenience again until the quota's full.
So it looks balanced on the surface, but the actual items picked within each bucket aren't necessarily representative of that bucket.
Exactly. You might just grab the first 300 urban images you find. This brings back convenience bias or maybe interviewer bias within the quotas. Like in market research, interviewers might just talk to people who look approachable, filling their quotas but missing key segments. You hit the numbers, but miss the real picture.
Got it. Then there's volunteer sampling. The self-selected crowd, right? People opting in.
Yep, that's it. Participants self-select into the study. Think online surveys, click share for feedback buttons, crowdsource data.
So you mostly hear from people who are really motivated or maybe have strong opinions?
Pretty much. That's the core issue. Volunteers can be systematically different from non-volunteers. It's self-selection bias.
Like getting only extreme views on a survey.
Exactly, or only really happy or really angry customers giving product feedback. You get a skewed view, not the average experience. You're hearing from an echo chamber, basically.
Okay, that's clear. Let's quickly touch on a few others. Deviant case sampling, focusing on the unusual. Why look at outliers?
Yeah, this one intentionally seeks out the outliers, the exceptions. It's valuable for understanding edge cases, rare events. Why did something break unexpectedly? Why did someone react totally differently? Learning from the atypical.
And critical case sampling, finding the vital examples.
Right. Selecting cases that are particularly important or informative. The ones that, if they hold true, suggest a lot, or if they fail, reveal a major flaw. In ML, maybe focusing on the hardest examples or failures to test limits.
Makes sense. And the opposite, typical case sampling.
That's looking for the average, the most common instances. The archetypes. Illustrating the norm, basically. Contrast directly with critical cases. One shows the rule, the other tests the boundaries.
Wow, okay. So we've covered a lot of ground there. Bringing it all together, what's the big takeaway for us listeners navigating all this data?
I think the core thing is always remember that trade-off. Practicality versus potential bias and limited generalizability, these non-probabilistic methods, they're essential tools, used everywhere.
Yeah.
But knowing which method might have been used and understanding its specific built-in biases, that's absolutely crucial for evaluating the information properly. It empowers you, really, to be a smarter consumer of data.
That's a really vital point. And it leaves us with a final thought, doesn't it? A provocative one. What biases might be lurking, maybe subtly, in the data you see every day? Your social media feed, news reports, recommendations. If they use these non-random methods,
Right.
how does knowing how that data might have been gathered change how you see things? Definitely gives you a more critical eye.